Scientists have found that the oldest star in the universe, Methuselah, is about 14.5 billion years old. Now, that's even more than the age of our universe, which is 13.8 billion years old. Considering it simply couldn't have appeared before the Big Bang, scientists have either miscalculated the star's age or incorrectly defined when the Big Bang occurred. And besides, our time system isn't perfect either, as it doesn't give us an adequate picture of the universe's overall history. For instance, life on Earth actually emerged almost 4 billion years ago. And within about a year, all the continents will merge into one. You probably think that's impossible, but it's not if we're speaking about galactic years. An accurate galactic clock will help us understand how much time it takes to conceive a star system, how fast it evolves, and whether the conception of humans became the best or the worst period of the universe's life. But the most terrible thing is that not knowing what period of its history the universe is going through, we're missing the moment when it and us respectively will die. So how soon will that be? The universe's lifespan is really comparable to that of a human being, which can be divided into childhood, adolescence, maturity, and aging. It's just that in space, time runs on an absolutely different scale than on Earth. But just like us, the universe started with a birth. Scientists argue that initially, there was a tiny little but super hot and mega dense, which at some point exploded out in all directions. We know this moment as the Big Bang. At the same time, the process of inflation began, in which particles of the initial ended up over 1 million light-years away from one another in only 1/1,000,000th of a split second. Despite that, physicists managed to divide this briefest moment into even smaller bits because at this moment, many of the events that were key to our universe occurred in 1/10 of a second to the power of -43. The incredibly hot of the universe, or more precisely, its time-space fabric, became a boiling mass. This was the moment when all the fundamental forces currently present in the universe, like gravity and electromagnetism, were united in a single superforce. When 1/10 of a second to the power of -35 began, this superforce fell apart. Inflation energy boosted a rapid expansion burst. That was the moment when a mixture of matter and antimatter formed. A few more split seconds later, this mix expanding became so cold that it developed particles of matter we know today, protons and neutrons, which would subsequently form the first atoms. And it all took less time than a hummingbird needs to flap its wing one time. The bird does that in 12 milliseconds. But all the following important events in the universe have lasted much, much longer. This is because after inflation, the universe continued to grow, but slower. The next important stage in the universe's life occurred at 14¼ hours. At first, the intensive heat caused by the universe's creation was making it too hot to enable light to spread. That's because atoms bumping into one another integrated into the solid opaque plasma of protons, neutrons, and electrons, which, in turn, diffused light like fog does. But during the first 380,000 years after the Big Bang, the universe's matter cooled down enough for electrons to conjoin with nuclei, creating atoms, which made the universe transparent, and light was finally released. I see you have a question. Why did we start talking about 14 hours, but now it's hundreds of thousands of years? The point is that we're used to observing cosmic events from our Earthling point of view. Yes, the Big Bang itself happened in such a short period of Earth time that it's basically nothing in galactic years. But all subsequent cosmic events, on the contrary, have lasted so long that trying to calculate them in Earth time is, well, almost stupid. And it might sound strange, but now we're going to view all the universe's most significant events in the way it feels them itself. Since what to us lasts for an eternity in space is one galactic year. This includes the time it takes for our solar system to orbit around the center of the Milky Way galaxy. Keith Hawkins, an assistant professor of astronomy at the University of Texas at Austin, gauged that to go around the whole of the Milky Way one time only makes the Sun approximately 230 million Earth years. This period is now deemed a galactic year, and the smallest split second of such a turn is called a galactic tick. One of these occurs every 6,337 Earth days. Hawkins also explained that other stars in the galaxy have absolutely different galactic years. If you imagine the Milky Way as a city, our solar system will be somewhere on the outskirts. For stars revolving in the city's downtown, it's relatively shorter than for us Earthlings. This disparity makes it difficult to be completely objective. But let's count at least roughly when the universe's first light was born. For this, we need to divide a galactic year, which consists of 230 million Earth years, by 12 to find out how long one galactic month is, then by 30 to know the length of one day, and so on. Given that 380,000 Earth years are not a huge number that probably won't exceed one galactic day, we'll divide it by galactic hours. As a result, the emergence of light in the universe took less than half a galactic day. After the first light streamed out, another period of darkness began, since bright cosmic objects like stars hadn't yet formed. But it took even medieval Europe longer to deal with the dark ages than the universe, which required less than 2 years to put an end to them. By then, in cosmic gas aggregations, the formation of the earliest stars and galaxies began. Their light destroyed the greater part of the surrounding neutral hydrogen, and then the universe, for the first time, became transparent for ultraviolet rays. Afterward, the moment that was important not only to the universe, but also to each and every one of us began. It occurred 41 galactic years after the Big Bang. Under the influence of gravity, one of the spinning gas and dust made nebulas accelerated so much that it flattened into a disk. This movement drew most of its material to its center, forming a sundae. At the same time, giant pieces of rock and gas clouds collided, merging and eventually forming planets and their satellites. For the universe, this time was something like a self-identification period. The celestial bodies it created made the universe look like we know it today, full of galaxies that, in turn, comprise star systems containing planets. This period resembles when a toddler takes their first steps. It's such a carefree time until a breaking point when they face their first serious problem. In the case of the universe, this problem was Earth. 20 galactic years ago, one such red-hot rock was spinning around the sun, undergoing severe impacts with other gigantic rocks. In these cosmic torments, our home Earth was conceived. It would be fair to say it was the universe's adolescence, when it became rather fiery and irritable, which is typical for this stage of life. It was especially apparent 17 galactic years ago when impacts with asteroids and meteorites were constantly occurring in our system. Back then, cosmic rocks of different sizes began colliding with planetary bodies, craters on the moon being proof of that. Some of the meteorites contained water and ice, so when they hit Earth's flaming lava, vapor began forming. It accumulated, creating the atmosphere and significantly reducing the planet's temperature. When it cooled down enough, magma turned into land, and then rains continued until Earth was completely covered with water. This is how almost 17 galactic years ago, the first global ocean appeared. At its bottom, it had craters, the depth of which emitted gases and chemical elements. It was then when lipids, carbohydrates, proteins, and nucleic acid DNA and RNA appeared. In this multi-component cocktail, the first microorganisms formed. Your most ancient ancestors look something like this. Can you see any similarities, maybe in the profile or facial features? Yes, we've changed beyond recognition, but we basically owe our existence to this little thing. To be more precise, we wouldn't be here unless it had been as aggressive and stubborn as it was. Scientists think that a little less than 17 galactic years ago, one unicellular organism attacked another, and the winner ended up inside the loser. Eventually, they became dependent on each other for survival and began cooperating as a single multicellular body. This is how some of the first life on Earth emerged. Thus, sponges, fungi, plants, worms, jellyfish, and snails appeared on the sea bottom. And in the following 5 galactic months, seaweed and fungi moved closer to the land. Yes, by Earth standards, as much as 100 million Earth years passed. But by cosmic standards, it's the same as if a baby learned to walk almost immediately after birth. During that time, the planet's ozone layer underwent dramatic changes. It became denser and more steadfast, which provoked a true burst in the evolution of life on Earth. The first creatures that went ashore gave rise to reptiles, birds, mammals, flowering plants, trees, and bees. The most interesting thing is that the gigantic T-Rex and other dinosaurs only appeared a little more than 1 galactic year ago. But as soon as 3.5 months later, they fell victim to a grand disaster. The thing is, 66 million Earth years ago, the Cretaceous Paleogene extinction event occurred, during which, after the asteroid impacted Earth, 75% of all Earth species went extinct. Fortunately for us, the mass extinction became fertile soil for a new evolution on Earth, especially among mammals, which replaced dinosaurs as the dominant creatures. But the most prominent event in our as well as the whole universe's history occurred a little more than a week ago when an ape stood on its hind legs and assumed an erect vertical posture. In 8 Earth days, scientists that conduct experiments on primates can teach AD, for instance, to use a stick to hook food from a closed box, but nothing more. But on the galactic scale, this time was enough for one ape to take on a path of utter and absolute importance to each and every one of us. The first humans appeared on Earth 4.5 galactic days ago. In Ethiopia,